All right, well, we'll try that with the other mic. So square of sum. Immediately by looking at the function name gives me some indication on what the hell it's going to do. Square of sum. Takes two parameters. And what does it do? Well, it takes a and b, adds them together, puts it into the variable c, then multiplies c with itself, effectively squaring the thing. Puts it into d, then we return d. The parameters are how I give information to the function. So if I call the function square of sum 2, 3, the parameter a, because it's the first one, will take the value 2. And then 3, the parameter b will take the value 3. Then, 2 plus 3 is 5, 5 squared is 25, return d. So it returns d. Let's just take this here. We should see 25 printed out, looks good. So 2, 3, a becomes 2, b becomes 3, a plus b is 5, 5 times 5 is 25, return d, we get the value back. The parameters are how we give information to the function. The return is how we get information from the function. But everything the function knows, this variable c and this variable d, and hell, even the parameters a and b, if this is me out here on line 6, I have no knowledge of those things. All I am aware of is that I have a function called square of sum. And I know what it does, but I don't know how it does what it does, which is fine, because I don't need to. All I need it to do is just do what it's supposed to do. Give me the square of the sum of those things. If you call the function with too few parameters, it gets mad at you. It says, well, I'm missing one. If I call it with too many, it'll say, well, you gave me too many. I need 2, you gave me 3. What am I supposed to do with that? Give it 2, which is what it wants, it's happy. Any questions about any of that? All right. Return. So like I just said, parameters, that's how I give information to the function. And then because whatever the function's doing, I have no knowledge of how it's doing what it does. All I know is that it gives me the square of the sum. But when it's done, because I have no way to access any information inside that function directly, we have return. Return is how the function gives me information. So parameters is how I give the function information. Return is how I get the information back from the function. So who's the volunteer? Who's going to raise their hand and just pretend to catch something and then throw something? All right. If I give you a 2 and a 3, you're square of sum. You're that function. I don't know how you do what you do, but I do know that you sum the things and then square it, and you're supposed to give it back to me. So I'm going to give you what you need to know in order to do what you got to do. So here's a 2 and a 3. Well, you only caught one. Catch the other one. Okay, there you go. So he's got it. Now you're going to do whatever you got to do. Great, and now you're done. You have the value 25, but I don't know you do. I don't know anything about you. I just know what you're supposed to do. I don't know how you do it. And I don't really care how you do it. All I care is that you do what you're supposed to do. That's kind of like an example of information hiding. I really don't care about how you're doing what you do. Have you ever cared about how print did what it did? Or did you just want print to print? Just kind of wanted print to print. You may have wondered, I wonder what it's doing. Whatever. You may have thought to yourself, I really want to know how my internal combustion engine works. Not just in theory, but really, right? Yeah. And then you never actually looked it up and you just got in your car and you drove because it did what it was supposed to do. I didn't really care. I didn't need to know that level of detail in order to use it for what I needed it to do. So I'm using you for what I need you to do. I need you to give me back the square of the sum of those things. And you've got that value 25. I gave you information. Now I can't directly access any information from you. But you can give me back information with that return. So we say return D. So throw it back at me. Got it. Now I've got that information. This is how the program can pass information between functions. Information to the function, information back from the function. And be aware, we can have functions calling other functions, calling other functions, calling other functions, and so on. We could do that forever. So yeah, the Celsius to Fahrenheit, I give this function the 20, I get back the 68 because that's the conversion. But again, I don't really know how that function does what it does. All I care about is that it does what it does. So I ask the function to do its calculation, give me back the result, I get the result, I'm happy. Okay, we'll skip this one for now. Raise your hand if you've gone to lab already. Raise your hand if you've not gone to lab, had lab, like you have lab today or tomorrow. Okay, cool. All right. We're skipping this because this is effectively what we're doing in lab. Okay, here, let's do this activity. We didn't do this one already, right? Okay, do this activity. Give yourself a couple minutes. We'll give yourself I'll give you like 4 minutes to actually do this one. Give it a go. See if you can get it working. Have fun. And remember, you're encouraged to work together, so it could be a little loud in here. Raise your hand if you're done. Okay. Keep going, keep going. If you're done, see if you can try to do it a slightly different way, just for the hell of it. Does anyone know how many ways there are to solve a problem? I heard a rumble, I didn't hear what they said. Yeah, you're right. Literally. U's looked more or less like this. Yeah. Anyone here do it just a little differently? Just for fun of it? Anyone else? Somehow slightly different? No? Did anyone, so no one did this by chance? Did anyone do it that way? Because I couldn't figure out the square root? Nice. So of course all I did is, because maybe I wasn't aware of like math.square root or whatever I just did to the power of a half, and okay, same thing. Yeah? Well, no, like this would do it, right? Whoa. Oh no, I just deleted everything. All right. Let's do it again. Here, so. Oops. So with the math.square root, this is what you're asking about, right? So what about it? Sorry. Well, the only way aside from the other way to do it is, sure, the only way aside from the other way. Yeah. And we will talk a little bit about an import. But what's happening here is, and if you Googled it, I mean, here's what you should have done, right? Math, Python. And you go, oh, okay, cool. Python square root, maybe here we go, right? The square root function. Here, if we go read here, let's pretend I say, oh, the SQRT function. Let's say this is your train of thought. And you go, okay, well, there's the math square root, right? So let's pretend we didn't have this. Let me restart the runtime as well. If you did this, it's going to tell you SQRT is not defined. And then you're going to be annoyed because you're going to be like, well, look, it just literally says square root function. It's inbuilt function in Python. What's going on? And yeah, it is. But when you load up Python, Python gives you a lot of built-in functions. There are a lot in what we call like the standard library of Python. And there's even more that you can get outside the standard library that are more or less standard anyways. There's a lot of functions that are there. But of course, most of the time you're not going to need them. So there's no sense loading up a billion functions if you're only going to probably need a few by default. Like your input, your print, yeah, you get those for free, you load up Python, they're there. And Python, it'll give you access to the square root function along with a lot of other math functions. They're built into Python, but they won't be included when you load up Python unless you really need it. Because there's no sense of doing all that extra work because you're probably not going to need it. But if you do need it, well then we do this math dot thing. So if you continue to read here and you're like, oh, I see, it's actually math dot square root. Okay. Oops. And you run it, and it's still going to be mad at you. And it's saying, well, now I don't know what math is. Well, yeah, it doesn't. So when you're reading like the guides, make sure you're actually looking carefully. Because if you look at this example, it's got this right here, import math. Now, when you say import math, you're telling Python, okay, all of that stuff in the math, I know you didn't load it up by default, I want it. That's what that means. Then if you want to access anything in there, you say, well, okay, math dot square root. From that math module, use the square root function. That's what that meant. execution flow. So look, Python runs one line at a time. And whenever you hit run in any cell, it starts at the first cell. So if I hit run on this, the first line of code Python's going to look at is line number 1. But it sees def Celsius to Fahrenheit. And it knows, oh, that's just a function. I don't actually run this right now. This is just the definition of the function. I'm just being made aware of this function that now exists. Then it looks at line 2 and it goes, oh, that's part of the function. Line 3, that's part of the function. Line 4, that's part of the function. Line 5, there's nothing there. Line 6, oh, line 6 is the first line that Python actually does really anything with. And what does it do? Well, it takes the value 24 and puts it into the variable Celsius. Then it goes to line 7, and then we call the function Celsius to Fahrenheit, and we pass it the argument here, 24. So we're doing a function call. We're giving a value, 24, to a function. And on that line, on line 7, we actually have to jump back up to line 1, because that's where the function is. It's going to go up to line 1, and then take the value that was in Celsius, 24, and puts it into the parameter temp in Celsius. It does all that calculation. It goes to line 2, runs that, goes to line 3, runs that, goes to line 4, it runs that. And when it runs it, it returns the value back to line 7. And it puts the result into the variable Fahrenheit. Next, we go to line 8, print it out, line 9, nothing there, line 10, sets the Celsius, line 11, call the function, jump back up to line 1, 2, 3, 4, return to line 11, line 12, we print it out. So with functions, Python's actually kind of jumping around in the program where it's actually running. So really, this is how it's going. Okay, it looks at line 1, line 2, line 3, line 4, line 5, line 6, line 7, line 1, line 2, line 3, line 4, back to line 7, line 8, line 9, line 10, line 11, back to line 1, 2, 3, 4, back to 11, then 12. So we're jumping all over the place, but it shouldn't be, there's no mystery to where it's jumping. Everything should make sense as to where it's jumping. If it was anything more confusing than it is, programmers wouldn't follow it. So it's just one line at a time. And how did I know the line jumped, line 7 jumped back to line 1? Well, because that's the function it called, which happened to be defined on line 1, at least starting to be defined on line 1. When it runs lines 1 through 4, all it's doing is just making, the first time it runs it, it's just being made aware, hey, this function exists. I actually haven't run that yet. But if I were to try to run this code right here, and I hit run, it's going to say, Celsius to Fahrenheit doesn't exist. Right, because I didn't actually include that. Once I define it, yeah, it's fine. Cool. Yeah, I'm aware it exists. Any questions about that? So once again, I know I've said it, and it might sound like I'm a broken record if you understand it, but the reason I'm saying it a lot is because this does tend to be an area of confusion for new programmers. Be aware of the difference between defining a function and calling the function. Huge difference. You only need to define it once. You can call it as many as you want. When you call it, you actually pass an argument. Remember the difference between argument and parameter? Argument is the value passed to the function. Parameter is the name of the variable that gets the argument. It's a nuanced difference. Now, we're not going to do this, but imagine I told you what? Write a program, or, we call it a program, or we could use words like, I could tell you to give instructions to someone on how to make spaghetti. But you're only allowed to use those operations there. Locate an object, grasp it, release it, move, link to, wait in seconds, right? So imagine what this would look like, okay? Locate drawer. Move limb to drawer, grasp, pull. Locate pot. Okay. Move limb to grab. Locate tap. Move, I don't know, limbs until you get there. The amount of detail I would have to go into is pretty high. There's nothing wrong with that, but there's a lot of detail. But like we said before, realistically, if I'm talking to another human, I could probably just say, grab a pot, add some water, maybe a little salt, let it boil, add your pasta, wait 9 minutes, and you're good to go. Obviously, that's a lot more simple than saying locate drawer, move limb, grab, pull, locate pot, and so on and so on and so on. But you gotta figure, though, those instructions that I would give to another human, grab a pot, do this, there's actually a lot to unpack there. My instruction to say, grab a pot. There's a lot that the human has to do. They are going to ultimately be doing those things. But I didn't need to tell that to them. Because inside their heads, they know what they got to do, and they know the smaller steps that make up that job. And so do I, so that's why I know, we can communicate at this level, not at that low level. And functions really start to facilitate those levels of abstraction. At the simplest sense, think back to the Celsius to Fahrenheit, right? Celsius to Fahrenheit, convert Celsius to Fahrenheit, I can tell that to you. And then you go do it. Okay, I gotta go look at the formula, go do this, whatever. Or I could just write the function once and then suddenly tell the computer convert Celsius to Fahrenheit, and now it knows what to do because I wrote that function. We could keep adding more and more layers of abstraction to make things even easier, which you'll do for assignment 1. Yeah. So if I were to tell you to do that, if I were to say, oh, by the way, you all saw the announcement today, test 1 is set, right? Well, if you didn't, it's in your email. It's next Wednesday, I believe. It's the 4th, I think. Whatever I say in the email is there. Lost my train of thought. Yeah, so if we did that, thinking of the program at 2 different levels, that's communicating the same thing, just at different levels of abstraction. And you've been making use of this. I've said it before, I'll keep saying it, print. Every time you need to print something out, you just use print. But there's a lot going on under the hood. If you were to really crack open that print function, look at all the code inside that function, because you didn't write it, thank God I didn't have to write it. You look in there, there's a lot of stuff going on in there. Thank God I didn't need to think about that. I could just say print and it just does it for me. Great. But if you go crack it open, you're going to see a lot more tiny little steps. I didn't need to think about how I was going to worry about where the pixels are and how everything's going to get rendered and everything. No, not my problem. I just said print and it just did it, thank God. Input. How it's actually doing that, I don't know, I don't care. I just want to be able to use input. That's the goal here. Now, when you're writing functions for yourself, you might say, well, okay, this whole thing about abstraction, like, oh, print. Like if I wrote the print function, and then I'm using the print function, this whole argument of, oh, well, if you open up the hood, you don't need to look and, like, I wrote it, so obviously I am aware of that. So the abstraction isn't really there. Well, yeah, 1, you're the one that wrote it, but everyone else doesn't have to do that. And 2, you only need to write it once, and then you can just call print every time you need it, even if you did write it. So it facilitates that abstraction, which makes our lives so much easier. Without being able to organize things into levels of abstraction, into what we call them like levels or layers of abstraction, like consider for a moment how we operate on a daily basis, right? Y'all got to work or school today, right? Y'all got here somehow. How many of you walked? How many of you drove? How many of you rode a bike? I said that because I know you ride a bike. That's the only. Anyone else get here any other way? Took a bus? I didn't think so. You didn't take the one bus in town that comes at inconvenient times? You all got here, but when doing it, did you think about move leg, move leg, move leg? Of course not. You didn't do that. You didn't even think, there's a lot. Not only did you not think about moving legs, you didn't have to think like contract tendons and muscles and extend and whatnot. There's even more there. You can start talking about your brain and signals going through your body. You can start talking about neurons. You can start talking about particles and ion pumps and how they're interacting with one another to describe how you got here. There's a hell of a lot that had to happen for you to get here. A lot of crap happened. A lot of like physical things actually happened inside your body, in your brain, all the way down to get here, but you didn't care about that because we don't operate at that level of detail in our lives. Thank God. That would be stupid. We wouldn't get anything done. No, we operate at a much higher level. We operate at a level where I say, grab a pot, add some water, let it boil. One's a lot better. And that's how we like to organize our lives. We do this. You're already experts at this. You're experts at working at high level of abstractions and creating even higher levels of abstraction as you go. There's a lot. You're experts at this. But what's interesting though is, first of all, knowing where to create that level, where to differentiate whatnot, this is a non-trivial thing. This is something that requires a deep understanding of a problem that you're trying to solve. There's also a difference between your intrinsic, intuitive understanding of how you operate the world, and then taking your intuition and turning it into something that you can actually use. Your intuition on how like you break down things in layers of abstraction, because you just do this without thinking about it. But now you need to actually take that and start using it very explicitly. And knowing when and where and how to create levels of abstraction is not trivial. This is a skill. If you're a programmer, this is a skill you develop every day of your life as you go. So don't think for a second you're going to hit the ground running on this and you're going to be an expert. Even though you are an expert in real life, taking what you do and applying it like this, not trivial. This is not something you're expected to be good at from the get-go. If you are, great. If you aren't, you're normal. If you are, you're not normal. But good for you. Keep it up. Yeah, okay, this is a warning. Look, it's even like red and pink to warn you. Yeah. Don't be mad at yourself. You are going to suck at it because, yeah, we all do. Any questions out of anything so far? Really, nothing. You're all good? You all understand everything we've talked about up until now? 100%? I could give you the test now and you'd be happy? All right, awesome. Great. I didn't realize I'm that good. All right, so we talked about very specific functions. We showed you convert Celsius to Fahrenheit. We did square of sum, right? Those are two examples, but the general structure of a format is something like this. Def function name. The function name could be whatever. There are other restrictions, just like variables, can't start with a number, can't use reserved words, whatever, but those will probably not bite you. And obviously, it could be called whatever. Like if I go here and say Celsius to Fahrenheit, I could call it this, hit run, and it's gonna work. But obviously this is a terrible function name. That doesn't really tell us anything at all. Celsius to Fahrenheit, on the other hand, much better. So we give it a good name, but the name really doesn't matter. Followed by what we call the parameter list. Really, it's just the things in the parentheses. Parameter 1, parameter 2, parameter 3, parameter 4, and so on. Could have a bunch of them. And similarly, these are just like variables. What we call them doesn't really matter barring the specific restrictions. and the fact that we want these to be called something useful. But we can have as many parameters there, and then inside the function, we can have as many statements as we want. But when we're done, the moment we're done writing code that belongs to that function, we unindent. Everything that's inside that function is indented. And the way Python knows what is and what is not part of the function is the indentation level. So we can clearly see here, these 4 lines, or these 3 lines are a part of this function, but these ones aren't because they're not indented. How do I know where it changes? Well, somewhere between here and here, because the indent and then not the indent. Some other programming languages, I will warn you, a lot of people love Python, right? Python's a great programming language, but there are a few specific things about Python some programmers absolutely hate. Your experienced programmers will look at it and be like, that's dumb, that's bad. And one of the things experienced programmers will hate on Python is how we distinguish what is and is not inside a function. And similar things in code that we will do. That whole indent thing. A bunch of programmers hate that. Some other programming languages have different styles. At the end of the day, it's just syntax. It's how we write what we write. It'll mean the same thing, but the syntax will be different. Other programming languages, you might see something like this. Open squiggle bracket. And then close squiggle bracket like that. And then when I want to know what's in the function, I look at the braces there. That's how I would know. In Python, we don't do that. In Python, we just use the indentation. But be warned, if you are, raise your hand if you do have some programming experience before. What language did you do? C++. So yeah, braces would be normal to you. And you? Java. Braces are normal. Java and C++ syntax is like that. Python's the weird one, right? So yeah, be warned. And raise your hand if you have experience with Java, C, C++, maybe even C#. Raise your hand really high, I want to see. Does anyone have experience with a programming language I didn't mention yet? Just out of curiosity? HTML? That doesn't count, that's not a one. But a little bit. You don't need any more than that. One thing, if you're familiar with those languages, if you create a variable in C++ or Java, what do you have to do that we haven't been doing here? Putting you on the spot. You remember? You have to specify the type that's going to be in that variable. In Python, we don't. It just figures it out. Yay. Isn't that great? Yeah, this is another thing experienced programmers will look at and be like, I hate that. We really want to have to like specify the types and whatnot. And I know, for those of you that don't know what I'm referring to, you can ignore everything I'm about to say. For those of you that do know, I'm giving you the warning now. You might be thinking to yourself, this is great, I don't need to worry about the types. You definitely want to wish you were worrying about the types. Because mixing up types can create a lot of bugs in your code. But when you are very explicit about the types of everything in your code, and like the languages like C++, Java, C#, when you're very explicit about your type, you can eliminate a lot of bugs before you even hit run. Whereas in Python, no, it'll get you. So even if you're like, oh, this is great, I don't need to worry about the types. Well, okay, have fun. And for those of you who don't know any better, very soon we're going to be talking about type hints and whatnot to help kind of mitigate this issue, so don't worry. Yeah?
If you really wanted to make sure that you were being specific about the types, then you use the functions for like converting things to strings or meters or
You could, but that's like a functional thing where you actually, like your code has to do that work for you as opposed to like even like at compile time stuff, like where it would make sure everything's correct before you hit run. But then those checks will have to happen at runtime. And then what happens if your types aren't correct? Does the program crash? Wouldn't it be better if the program didn't run in the first place, and then you were thinking, oh, everything's, if it's running, you might be thinking, oh, everything must be great, and then all of a sudden it crashes, uh-oh. Yeah. We'll see as we go. Other questions? Awesome. Okay, here's an activity. I want you to write a function. It's probably, you could do it in like, if you're like me, I would probably write this in 3 lines. Write a function, concatenate strings, that takes 2 strings as parameters and returns the concatenation of the strings. For example, if I call concatenate strings, hello world, it would return hello world, like that. Don't add a space. I mean, you can if you want, it doesn't really matter. But make sure you're returning that. I'll give you a few minutes to do this one. And for those of you that forget, who wants to remind everyone? How do we concatenate strings again? Someone yell it out. Come on. Yell it. There you are, if you heard. Here's my solution. Defined it, concatenate strings. I gave the parameter names, string 1, string 2. What other parameter names did people use? AB. Anyone use like AB? Use AB. Anything else? What else? Used AB? Anyone use anything else? I'm just curious if people chose. All right. So there we go. I take the two parameters, and remember, you gotta think, like when we're defining the function, don't even think about the values yet. Just be aware of the variables. I want to concatenate the values that are in those variables. And then if you say, yeah, but what are the values? It doesn't matter right now. We're defining the function. There's no value left. Take string 1, add it to string 2, put it into the variable concatenated, then return concatenated. Line 5, did it work? That's the name of my variable, just, for testing purposes. Called concatenate string on hello world, hit run, there, it works. It's not until we get to line 5 where the values are assigned to string 1 and string 2. Any questions about this function? Yeah?
Line 5 and 6, does it work? Can you explain that to me?
Right here? So first and foremost, this could be called whatever. Right? I just called it that, right? Just because it's just a variable. Now what's happening on line 5? Let's start by talking about line 1. Line 1, Python starts running it. We define a function called concatenate strings that takes 2 parameters. Cool. Line 2, it's part of the function. Line 3, it's part of the function. Line 4, there's nothing there. Line 5, clearly we're outside of the function. So, remember, we always go to the right-hand side of any assignment first. Concatenate strings. I call the function concatenate strings with the values, the string hello in the string world. We jump up to line 1, and line 1 because that's the line that the function's defined on. String 1, what value does string 1 take? What value does string 2 take? You? Yeah. Line 2, string 1 plus string 2 is just, well, hello world. No space, just smushed together. Return concatenated. Great. So if I give you, you're the function. Hello world, ketchup. Okay? Now, smush them together. Now throw it back to me. Great. You are running lines 1, 2, and 3. And when you're done, returned, I'm line 5. Put the result into QWE, line 6, I print it out. Does that answer your question? When in doubt, follow the code. There's no magic beyond what the code's actually doing. So line 5 is calling that function. Now, I want you to write another function. Where I want you to concatenate 4 strings together, but I'm giving you some restrictions. I want you to return it such that it's the first, third, second, fourth. So the order of the concatenation is the first string, third string, second string, fourth string. So not just like 1, 2, 3, 4. I want you to kind of change the order up. And I want you to concatenate those strings and return it. But you are not allowed to use plus inside that function. You can't do it. It's against the rules. What you are allowed to do, however, so I just told you you can't use plus directly. And now you're going, well, but that's how I concatenate things. You're right. But here's what else is true now. You have a function called concatenate strings that does what? Concatenate strings. So use that instead. Don't use plus, use concatenate strings. Did anyone get it yet? Who here thinks they know how to get it at least? All right. Okay, we're going to end here and we'll pick back up here whenever next class is. Is it Wednesday or tomorrow? I can't remember. No? None of you know? Wednesday? I shouldn't judge you because I don't know. It's whatever's in my calendar. But what you should do, this question right here is your first true test of understanding. So try to get it working. And if you can, you're in good shape. That's awesome. You should feel confident. If not, that's fine, but this is your first thing where it's kind of testing you. What's up?
What chapters are tested you got right now?
Everything up to whatever we do the time before the 4th. I don't know what chapter it'll be, however far we go. That's more than 2 weeks from now. Yeah.